Okay, hello everyone. Today I want to go over the makeup test for the substitute test 3. The main reason why I want to do it because the test tomorrow will be identical, so test 4 is identical with one small difference. So here problems 1, in problem 2 you have to compute areas of regions. In the test 4 tomorrow, these two problems will be merged. So you will have a 30-point problem in which you have to find an area of a region, and then you have to rotate the region around a certain axis to compute the volumes. And in both things, setting up the areas, you have to use vertical and horizontal slices, and the same for the volume. So it will be a 30-point problem with areas and volumes of solids generated by rotating these areas about certain axes. And this is the main part of the lecture today. Before we go there, let's go first over the core of integration, and that is U substitution and basic integration tricks. So that is problem number 3, which most likely will remain a 60-point problem. If I need 10 more points, then I move 10 points to problems 1 and 2. But problem number 3 will remain a key element of every test on integration. Problem 4 is the fundamental theorem of calculus, how to use it. You find the solution of this problem online, so I posted the PDF file. You can also look at Khan Academy, where this is explained. I think the solution you find online should do it. And then, if time permits, I want to do the bonus problem B, the proof of the fundamental theorem of calculus. And I want to do this because it's relevant for the final exam. Okay, so main thing today is problems 1 and 2. And as a warm-up, I start now with problem number G from problem 3. Problem 3G, that is the integral from 0 to n of e to the minus 2x times e to the x plus 1. So for this I have to switch screens. So let us do this problem, and there are at least 2 ways to do it. One way would be U substitution. And the other way is, in this case, you just multiply it out. That's certainly the easier way. E to the minus 2x times e to the x. You add the exponents. It's e to the minus x. I'm not sure if I did this right in the solution sheet. Now I'm questioning myself, so I'm not sure, but this is correct. And now you know how to integrate it. The antiderivative of e to the minus x is minus e to the minus x. The antiderivative of e to the minus 2x is minus 1/2 e to the minus 2x, where you plug in 0 and n. And if you plug in n, you get minus e to the minus n minus 1/2 e to the minus 2n, minus, if you plug in 0, you get minus 1 minus 1/2. Now I'm almost sure I did it wrong in the solution sheet, and if you figure this out, then you get 3/2 minus e to the minus n minus 1/2 e to the minus 2n. Another way would be doing it would be with U substitution. If you take U equal to e to the x plus 1, then you have e to the x is equal to u minus 1, and you have du dx equal to e to the x. And now if you substitute this all in, then you get the integral. If I plug in for x equal to 0, you go from 2. If I plug in for x equal to n, it's e to the n plus 1. It's e to the minus 2x. I leave it because I don't know what to do with it at the moment. Then I have here u, and dx is the same as 1 over e to the x du. Use this one here. Dx, if I solve this, dx is 1 over e to the x du. So it's the same as the integral from 2 to e to the n plus 1. E to the minus 2x divided by e to the x is e to the minus 3x times u du, which is the same as the integral from 2 to e to the n plus 1 of 1 over e to the x to the 3 u du. And now, what do I get? It's the integral from 2 to the e to the n plus 1 of u over u minus 1 to the 3 du. Yeah, now this is again a difficult integral. Now I have to continue, make a w substitution. And then we continue, and then after a lot more work, then you will get out the same result over there. So if this is a 5-point problem and you get up to here, this would be 4 out of 5 points. Certainly in this case, doing first the algebra, it's much easier. Okay, that's problem number 3G. And again, I think what I posted online is wrong. So after the class, I will go there and check if I have to repair this. Okay, now the main thing for today, problem number 1. Volumes of objects that are revolved are about a certain axis. And in this case, so we take now y equal to the square root of x. One curve, the x-axis, another curve, and everything between 0 and 4. So we have the root function up to x equal to 4. So we talk about this region. And now the area of this region, the easiest way to do it, if you do vertical slices, then it is height square root of x times the thickness is dx, so square root of dx times dx, that is the area of that small rectangle here. And if you do this for all x between 0 and 4, that gives you then the total area. It's x to the 1/2. The antiderivative is 2/3 x to the 3/2, where you plug in 0 and 4. So it will be 2/3 times the square root of 4 to the 3. Square root of 4 to the 3 is 64, that's 8, so it is 16 over 3. And if you use horizontal slices, Then you fix a y between 0 and 2. Then if y is squared of x, then x is the same as y squared. So if I fix a y here, then the x value that belongs to it is y squared. So the length of the blue line is 4 minus y squared, so that is the length of this line here. Right minus left is 4 minus y squared. I multiply this with the thickness of the rectangle, that is a dy, and I add this all up between 0 and 2. That should also give me the area. So in this case, it's 4y minus y to the 3 over 3, where I plug in 0 and 2. So it's the same as 8 minus 8 thirds, which is 24 thirds minus 8 thirds. So again, yes, it's 16 thirds, that is correct. And now what we are doing is rotating this area around a certain line, a certain axis, and I do this now completely arbitrary. So let me draw this again. So let me do first like this. So again, we have here our region. And let's rotate it around the axis x equal to 6. Yeah, if you do this, then you get a ring structure, a spaceship structure, where in the middle a cylinder is missing, and then you have a ring around it. So to compute the volume, again, we start out with vertical slices. In this case, the vertical slice rotated about the line x equal to 6 will generate a shell. And for a shell, the base formula is 2 pi radius times height times thickness. Now, what is the radius in this case? The radius, if I rotate a red line about the axis, the radius will be the length of this little curve, that is the radius. So the radius is the right minus the left. The right is 6 minus x. The height is the square root of x. The thickness is a small increment in x direction. The thickness of the shell, the mantle of the shell. And you do this for all x between 0 and 4. And now you plug this in your calculator. Use the definite integral command, and you get a number, what it is. And even though the problem will say set up the integral and do not evaluate, you still evaluate, because now you have to make sure that if you do it with horizontal slices that you get out the same number. So for your own purpose to check it, always use your calculator to compute the definite integral. Okay, now we do horizontal slice. In this case, if you rotate the blue rectangle about the line x equal to 6, you will get a washer. And the key formula for the volume of a washer is pi the outside radius squared, the big radius squared, minus pi times the small radius squared, and the whole thing times the thickness. Now you have to go back to the image, and in your case figure out what is the big radius and what is the small radius. And so again, we fix the y between 0 and 2. And then, since if y is the square root of x, x is equal to y squared, if you fix a y, the x value that belongs to the y will be y squared. So the big radius is from here to there, which is right minus left, so this is 6 minus y squared. So the big radius is the right, which is 6. In the left, x value is y squared, so it's 6 minus y squared, minus, what is the small radius? The small radius is from here to there, so this is 6 minus 4, which is 2. And the thickness is dy, and you do this for all y between 0 and 2. And now again, you plug this into your calculator, compute the definite integral, and you get out a number. If the two numbers are the same, you know you did it right. If the two numbers are different, then at least one of the integrals must be wrong. So let me do the same problem again. Now we just use a different axis of rotation. So again, I take y equal to the square root of x, or x equal to y squared. I take this curve and look at it, this region. But now I rotate it about the line y equal to -4. So doing this, I take first again a vertical slice. Vertical means everything is an x. And then it's one of the rules that is always true, the only rule maybe. So everything has to be an x. And if you rotate this red slice about the line y equal to -4, you will get a washer. And so the key formula you will use, pi times the big radius squared minus pi times the small radius squared, and this times the thickness of the washer. Now, what is the big radius? That's from here to there. So in our case, it is pi times the upper minus the lower. The upper is square root of x minus the lower, which is minus 4. That is the length, that's capital R, and you square it. And what is the little radius? The small radius is from here to there. And that will be always 4. The upper 0 minus minus 4. So it is 4. So it's minus pi times 4 squared. And you multiply this with the thickness, which is a small increment in x direction. And you do this for all x between 0 and 4. And that will give you the volume. And again, use your calculator, the definite integral command here, and figure out what this is. And now we use horizontal slices. So again, I fix a y between 0 and 2. Then this value here will be y squared. X is equal to y squared. And if I rotate the blue rectangle about the line y equal to minus 4, everything has to be in y's. Horizontal always means everything has to be in y. And in this case, that is now different from case to case, we will get a shell where we have 2 pi radius times height times thickness as our base formula. So if I rotate the blue line about the line y equal to minus 4, then the length of this line, this will be the radius. If I rotate about this, then this is the big radius. So we get 2 pi. How long is this piece? The upper is y. The lower is minus 4. Y minus minus 4 is y plus 4. This is the radius. The height is from here to there. That is the height of the shell. It's the right minus the left. The right is 4. The left is y squared, so it's 4 minus y squared. And the thickness is a small increment in y direction. And you do this all y between 0 and 2. You add this all up. Now you use the definite integral command on your calculator. You compute the number. And again, if the two numbers coincide, you did it right. If not, you have to do it again. So that is the main problem, a 30 or 40 point problem where you have given an area, you have given a region, you have to compute the area, and then you rotate the region about 1 or 2 axes, and that gives you then the volumes. It will always say set up the integral, but do not evaluate. So for your own purposes, you don't have to evaluate. If you want to check if your answer is correct, you evaluate it anyway and compare the numbers. If you don't know how to deal with in a test situation, please send me a text. Please give me a phone call. You can do this during the test and ask a question, see if I can help you out if it doesn't work out. Okay, last thing for today is I want to do the fundamental theorem of calculus. Once again, prove the result, part 1, why the definite integral is always an antiderivative of a function. So this was a bonus problem in the MATLAB test. It will be a problem in the final exam. It is a key problem. So for the last 5 minutes, again, the proof of the fundamental theorem of calculus. So we have here a function f of x. Let's call it f of t. And then we fix an x between a and b. And we look at the area under the curve between a and x. So if you fix here a t, then f of t dt is the area of this black rectangle. You sum up all these areas between a and x, and that gives the area of the curve. Now, if you want to know what the derivative of this function is, you have to compute the differential quotients, a of x plus h minus a of x over h. Which is a of x plus h. That is the area under the curve. Between a and x plus h, minus the area under the curve between a and x. And what you get then is 1 over h times the area under the curve between x and x plus h. So it's 1 over h times the area under the curve from x to x plus h of f of t dt. So that is the first thing. So this is basic algebra. There is not much match. It's just a definition. Look at the definition. What is a of x plus h minus a of x over h? Okay, and now we use the second key element of integral calculus. There you know that the integral from a to b of f of t dt, if we use Riemann sums, that is the same as the limit if n goes to infinity of b minus a over n times, if you use the right endpoint rule, then you have f of t1 plus f of t2 plus f of tn. This is the Riemann integral, that is the Riemann sum. Or if you divide it by b minus a, then the b minus a here goes away. Then you have here 1 over n. So that means if you divide a definite integral by the length of the integral, you get out an average. And now we use this, the second bullet together with the first. And now we are done with the proof. So now we know that a of x plus h minus a of x over h is the same as 1 over h, the area between x and x plus h of f of t dt. But this is, by the second bullet point, nothing but the average of the numbers f of t for t between x and x plus h. So in this case, a is equal to x, b is equal to x plus h, b minus a is h. So it's nothing else than the average of f of t for a is x, t between x plus h. Now if h goes to 0, this is the definition of the derivative. And if h goes to 0, then it's the average of f of t for t between x and x. But there's only one number between x, and that is x. And the average of one number is the number itself. So this is then equal to f of x. And that is the fundamental theorem of calculus part 1, that the rate of change of the area function is determined by the height. So if you look at this function here, and you want to know what the derivative is, that's dA dx. Now if you change x, what is dA dx? So this is, if I change x a little bit, then dA dx changes by this red area. And the red area is about the same as the height at x is f of x times dx over dx. This cancels out, so this has to be f of x. So this is dA. If x changes, the area changes by this little this red rectangle here. And the area is approximately f of x, that's the height, times dx. So dA over dx is the same as f of x. Or if you want to do it a little bit more spiffy, you do it with the averages. There's a little bit more mathematics in there. And both of them are okay explanations of the fundamental theorem of calculus. That's all for today. Tomorrow, substitute test 4. Tuesday, Wednesday, I go over substitute test 4 and will hand out the first practice final, which we will go over this practice final then on Wednesday also. Thursday, I will hand out the second practice final. Friday, we discuss it all. Maybe we have a second practice final if you want to. And then the test will be Friday, May 8th at 10 o'clock. Any questions? no questions, then I thank you all. Huh? And I see you tomorrow for the substitute test 4.